Hello and welcome to my second of 4 videos on the chemistry of life. What I'd like to do in this video is give a quick refresher on the periodic table, mostly concerning electrons, and then go into the 3 kinds of bonds that are prominent in biology. And those include ionic bonds, covalent bonds, and hydrogen bonds. So here we go with the periodic table. Alright, so remember last time I had talked about mainly biology uses the first 3 rows of the periodic table. So those include the hydrogen right here, that row, the hydrogen and the helium, and then the second row here, and the third row. And if you count across, there are 2 elements in the first row, 8 elements in the second row, and 8 elements in the third row. And so when we look at some molecules coming up, you'll see that the first orbital or first shell of all atoms contain a maximum of 2 electrons. And then the second orbital contains a maximum of 8 electrons. And the third contains also a maximum of 8. And again, once you get beyond those first 3 orbitals, it gets a little weird, but that's chemistry. Alright, so next up, ionic bonds. Alright, so here's ionic bonds, and the definition for ionic bonds is a bond that happens when electrons are transferred from one atom to another. So a classic example is sodium chloride, and you'll see that sodium has a total of 11 electrons, if I can count, 11 electrons, and chlorine has 17. So what happens is sodium wants to have it's got one electron right there. So in its third orbital, it can hold up to 8. So it either needs to get 7 more, or it can get rid of this electron. And that's what it does. It gets rid of that electron. If you look over to the right-hand side with chlorine, you've got 17 electrons, and in the outer orbital there are 7 electrons. So it can hold 1 more, or it could get rid of 7. And it's a whole lot easier for chlorine to pick up 1 more electron and get that outer orbital full. So what happens when these 2 elements come close together is this electron on sodium is actually removed and sent over and attached onto the chlorine. So now, instead of, if we look at electrons, we have a total of 10 electrons here, and we have, for electrons on chlorine, we now have 18, but the protons have stayed the same. So protons for sodium are still 11, and the protons for chlorine, protons have a positive charge, there's still 17 protons there. Sorry, I missed the proton, the plus sign over here. So now what's happened? We've got an unequal number of protons and electrons. So overall, because that electron has left sodium, it now has a positive charge on sodium overall. And chlorine has a negative charge. All right? And now what you've created are 2 ions, okay? So an ion is an unequal number of protons and electrons, hence the name ionic bond. All right, next up, covalent bonds. All right, so covalent bonds occur when valence electrons are shared between 2 or more atoms. So if we look in this picture, this is called methane. CH4, and hydrogen has, if you look in the periodic table, hydrogen has 1 electron, and carbon has 6 electrons. So the atomic number of hydrogen is 1, the atomic number of carbon is 6, and hydrogen, because it's in the first row, wants a total of 2 electrons. It can hold 2 in the first orbital, and carbon can hold up to 8 electrons in the second orbital, and so it wants 8 electrons. And so how does that happen? Well, you've got the hydrogens in this picture are colored red, so each of the red dots here, that's an electron from hydrogen. Same with this one, and this one, and this one. So all of the red dots represent the electrons from hydrogen, and the blue ones represent the electrons from carbon. Now, electrons move really, really fast around the atom, and so when they get close together, these electrons are going to, like if you look at these at the top, these two electrons are going to move really fast around the hydrogen. Right? They're going to go around the hydrogen, and then they're going to go around the carbon as well. But they move so fast that hydrogen thinks it has 2 electrons, and so it's happy. And carbon thinks it has 8 electrons, and so it's happy. This is probably one of the most commonly found bonds in biological systems. So next up is the hydrogen bond. All right. Alright, the last kind of bond is called a hydrogen bond, and a hydrogen bond can be defined as when a hydrogen on one molecule is attracted to an atom on another molecule. So in this case, there's no electrons moving around being shared between, like within the bond. And so in this case, what you've got is this right here, this dashed line, all of this. This represents a hydrogen bond. And that is the attraction, in this example, between 2 water molecules. So you have an H2O over here, and you have an H2O over here. So 2 water molecules. And if you look within the water molecule itself, you've got a bond here and a bond here. And those bonds are actually covalent. So you've got, this picture is a little complex in that it has 2 different bonds. But the covalent bond, the reason that you get an attraction between this hydrogen over here and another atom, in this case oxygen, right, is because when the electrons are shared in the covalent sense, they're actually shared unequally. And so when the electrons are moving between the hydrogen and the oxygen right here, the electrons actually spend less time around the hydrogen and more time around the oxygen. And so remember that electrons have a negative charge, and if they're spending less time around the hydrogen, that's going to give a slightly positive charge to the hydrogen. And because the electrons are spending more time around the oxygen, then relatively speaking, you've got a slight negative charge on the oxygen. Now, what is that symbol there, that like almost 8 or like weird looking S? This is actually the Greek letter delta. So in Greek, the Greek alphabet, right? You've got 24 letters, and in our alphabet we have 26. So there's actually 2 less alphabets, 2 less letters. So the attraction here, what I want you to focus on, the hydrogen bond, occurs between a slight negative right here with the oxygen and a slight positive. That seemed really confusing. We'll probably have to go over that in class because I drew a lot on that picture. But hopefully it makes sense, right? Attraction between a hydrogen, which has a slight positive charge, and an atom on another molecule, a separate molecule that has a slight negative charge on it. All right, there's the 3 bonds. See you tomorrow.